the odds were terrible. I had a 30% chance of survival, based on just how aggressive the treatment is and just the likelihood of recurrence. So terrible odds, but really, this sense that you have no choice but to go forward, right? And you could either give up, right? Or you can fight, and you could really try to develop a positive attitude and go forward. I think that we talk a lot about spiritual, people's spiritual relationships or religious affiliations. There's something tangible there too, right? I think that the mind, the spirit, the positive attitude, in healthcare is a real thing. People that, medically may be doing well, but if they have a poor attitude or outlook or hope, have lost hope, they don't do as well. And so I think that's something that we, tend to forget about sometimes in the whole holistic treatment of a patient.
Welcome to the UIUC Talkshow. Our goal with the show is to introduce you to the most interesting people with the most interesting ideas. Today we have a very special guest, Dr. Boppart. Welcome.
Thank you. Really glad to be here.
So I want to start with a more philosophical question. Mm-hmm. So the other day we were having a discussion and everything from the beginning of the universe to perhaps the end is that everything seems to be an oscillation. And you've done some work with quantum coherence, which is this idea that all objects, they have a wave-like property. Mm-hmm. So do you think everything is an oscillation, or even better, a wave?
Oh, well, my research area is in photonics, biophotonics, and optics. So we're constantly thinking about this duality, right? Is light, wave, or a particle? Mm-hmm. And so, I think you talk about oscillations, and I think the life around us oscillates, has rhythms, has circadian rhythms that we know about. We live by the light and dark cycle. And we see that all the way down, not only at the organism level, but all the way down to the cellular level. And a lot of the research that we do too is about quantum control, coherence, using light to modulate biology and processes. That's a very fundamental approach. But yes, I agree. I think that there is this inherent cycle rhythm in life, right? And in what we do. And we see glimpses of that in some of the research.
And in a way related to the question, do you think at some point we'll discover that biology is really about, is ruled by quantum mechanics and quantum physics? Sometimes it seems to be the case, but we don't really get to it. Like, do you think that will ever happen, or what do you think is the fundamental?
Yeah, I think that's the debate that's out there too, right? Is that there's quantum mechanics, there's a lot of, quantum aspects to non-biological systems. But when you start talking about biological systems, the debate is out there whether or not biological systems operate under quantum-like principles, or do they just respond to it? And so some of the research that we've done, we use optical pulses, and we shape those pulses in such a way that when we shine them on cells, that we can control the way the cells respond and behave. And so is that because the cells are operating under some quantum biology principles, or are they just responding to sort of this quantum effect, right? That the stimulus that we're delivering to them. So I think that's an open-ended question. We don't know yet.
I don't think you can ever isolate the sciences from each other. You can never do truly physics or truly chemistry. I think every phenomena that you do study, it will have a blend of all of those. I think it's just a mental model that we bifurcate all of these into physics, chemistry, biology, right? But I don't think you can ever get purely one of those ever, because even if you're studying skin cells or any biological function, that would still be governed by the laws of physics, and it would have some chemical interpretation to that process as well. So
absolutely, I think this is where interdisciplinarity comes into play, right? That we have these established fields that have been built upon for decades trying to maybe almost silo them into areas because the amount of knowledge, right, in each of those is so complex. It's so deep that people have to spend, their efforts to dive deep into one particular area. But I think that's what's really exciting about these interdisciplinary fields of areas like bioengineering, for example, combining the biology with the engineering, or places like this Beckman Institute where we're at right now, and which was founded on interdisciplinary science and engineering and technology. So I truly believe that the next great round of discoveries are going to happen at these interfaces where you bring, these disciplines together. Now, people call this interdisciplinary science or transdisciplinary or multidisciplinary. There's many different names, team science. But I think, we recognize that some of the complex challenges we face or the major questions we're trying to answer are going to have to be answered by teams from multiple disciplines. And so bringing them together in different ways to solve those problems is the way to go. And
this is where we find you really interesting as a person, because we always say that the people who we try to talk to are people who are sane, when most people are crazy. Mm-hmm. And from your background, you've done engineering, and you've done doctor, and you've also done started a couple companies. And I do think in the common discourse seems to be you should specialize and do nothing else but your thing. Mm-hmm. And mm-hmm. you seem to be following a different type of curiosity and, mm-hmm. and like you said, mm-hmm. learning about different things and merging them together.
Mm-hmm. Absolutely. I think that, to me, I think that's what's most exciting, is that you can actually, obviously have to go deep enough in your disciplines to know the field, to know what's been done, where the questions still remain, what the limits may be. But I think, again, that interesting part comes when you take your expertise from one area and you look now at a different area or a different culture. So yes, I've been trained in engineering and medicine. And so for me as a doctor to walk into a hospital and to see the way that they operate, their processes, their workflows, how we care for patients, but to look at that with the lens of an engineer is a completely different view. Mm. And so and that applies to all these disciplines. So trained in one, but immersed in another. And when you do that, you start to ask questions that people have just never thought to ask. Or you come with your own skill set of solutions that they've never been able to tap into. So things like our Carle, Illinois College of Medicine was built on this premise, right? To train physician innovators, that to be the compassionate, caring physician that can care for patients and their health, but to really have them come from a skill set or a background in engineering or quantitative sciences. So they look at those patient problems with a very different perspective. And hopefully they come up with new solutions that haven't been thought of before. So this applies, I think, all across many areas.
Right. And you have a background in electrical engineering, and then you entered medicine, right? So do you have some example or some incident that you remember where you were like, oh, damn, I'm so glad I have this background in electrical engineering and it's helping me be a better doctor, or like vice versa?
Yeah, absolutely. All the time. I think that, yes, I started off in engineering here at the University of Illinois as an undergraduate and then a master's student. And actually I got excited as an undergraduate, getting involved in research, bioengineering research. And I was fascinated that, here these neurons, little cells, right, have all these electrical properties, and how do they function, right? They're a bag of salt, and yet they have all these communication properties and signaling properties. Well, that led to, to kind of this interest in both areas. And then further training, in my doctoral program, thinking about, I was doing more imaging, optical imaging. And I was imaging all these different tissues and different biology. And then, I started asking, well, why does the tissue look that way or, behave that way? And that got my interest into medicine and how again, trying to understand that culture from a different perspective. But you're right. So examples are, when I was in medical school and as a resident training, there were just so many instances that I would learn from patients on their challenges. So, for instance, one challenge that a patient had was that they had to get up at night to go to the bathroom, and they were afraid of tripping over things, their slippers, or getting to the bathroom. And so, as an engineer, the solution to that is obvious, right? You could have little things, lights that turn on automatically. You could have sensors that make sure the pathway is clear. You could guide. You could have all these, types of devices or sensors that could really help this patient's problem. And yet, these are undergraduate projects, but could still really have an impact on patients. So it's again trying to think about, combining these two cultures and solving these problems. I think another way around the vice versa is, as a patient, right? Patients have come in, things have changed, right? The patient-doctor relationship has evolved over the years. And because of the availability of information on the internet, and patients are much more educated, right? They are much more empowered with information. Now, it may not be the correct information, but they have a lot of information when they come in. And part of like what we've tried to do in this space, where in the Beckman Institute, in this lab is essentially like a doctor's office, is to say, how can we have technologies that produce images that we can share with patients, so patients become part of their treatment, more engaged. If you show, for instance, we do a lot of imaging in the ear, and we have systems that can image your eardrum and show you an image of your ear. How many of us know what our eardrum looks like, right? Or have seen that? But when you show it to a patient, the patient now kind of understands why, they have an infection, why they need antibiotics, or maybe don't. And they're just more engaged. So I call it shared care, right? You're really sharing this care experience and empowering the patient. The other advent, is the Fitbit revolution, right? Or our wearables. Our technologies and sensors have become ubiquitous, right? We've got smart watches and devices. So as a population, we are much more in tune with our own physiology and our own health. And that, I think, has changed, our perception as individuals, right? We know more about our health, our parameters. The next step, of course, is how can we use that information to improve our health in different ways.
And I think that, medicine has always been about, ideally would be about prevention instead of curing. And it's been so far about, it's too late and that you kind of cure it. And I think with sensors and wearables and all these technologies, we'll get to a point where it will be about, medicine will be about prevention in a way.
Yes.
But that hasn't happened yet.
Yes.
So let's say that we take you here and we'll put you in, in the year 2090 per se, and that world is there.
Okay.
What like from your perspective, what are the key components of a medicine, of a field of medicine that is all focused on prevention? What are the components? Describe it to me. Like, what does it look like?
Yeah. Well, you raised some really good points. First off, I see medicine as being a subset of health, right? Medicine is when you get sick, right, or develop an illness, and you need to have your health restored. But a much greater impact is our health, and whether that be mental health, physical health, community health, public health, rural health, all these environmental health, all this matters to our health. There's some ideologies out there that speak to this. One is the One Health Initiative, which means it's not just about our health, it's the health of the planet and our animals and our environment. The other is this concept of the exposome, where we have our own genetic makeup, but it's how our genetics respond to our exposures and our stimuli, our lifestyle. Do we smoke or drink, or what's the environment that we live in, social factors. So it's really the intersection of all those exposures and our own genome that lead to our individual health. So these concepts all speak to this, right? That it's much broader. So in the future, I think more of this is going to be appreciated. I think that, in fact, if I were to predict the future, I would say that the way that we monitor our health, respond to interventions, treat disease is going to be completely different from what we have today. Hospitals, we've got an aging population, in the U.S. and in many countries, and so our our assisted, our elderly care, our hospital systems probably cannot keep up with this huge increase in care that's going to come. So I predict that chronic medical care is going to move from the hospital to the home. The hospitals will be for acute care, for trauma, for emergencies, where you need that right away. But in terms of monitoring for health, delivering medications, treatments, monitoring status, all that will take place in the home, right? Or on yourself as a wearable. And so it's almost the return of the house call, right? Where the doctor used to go to the patient instead of the patient going to the doctor. And so this is going to mean we've got wearable technologies, we've got at-home sensors, we've telemedicine has proven its worth in the epidemic, in the pandemic, and so we're going to continue to see more of this develop. I think we're going to have a very different type of healthcare delivery model going forward.
You think? So you're describing it to be more decentralized in a way? Because
Yeah.
I was looking at your research lab, like the biophotonics one,
Mm-hmm.
and I saw one of the core principles of the group is decentralization, right?
Yeah.
So that's why when you were talking about this, I thought about it. So
Well,
what you were describing did feel a little decentralized and
Absolutely, yeah, it goes with the same theme that, with this interdisciplinary theme, right? It's not one single discipline that's going to solve the problem. It's not, in the case of a lab, it's not just me as the head of the lab that's going to solve all the problems. It's not just one, hospital or doctor that's going to solve all the problems. It's got to be a decentralized approach. And in my own research group, I'm not the expert in everything, but we have somebody, the postdocs and students that are expert in machine learning and maybe ultra-fast lasers. And it really is about empowering people to be their best. And everybody's an expert in something, right? And you should be viewed as that. And collectively, though, you can do something far greater than anyone as an individual. So that's the message of this decentralized approach. And from the healthcare perspective, taking that even a step further, we like to call this the democratization of healthcare, meaning that healthcare and health innovation, meaning that these ideas for improving your health, they don't necessarily come from the doctors or the faculty or those types of visionaries. They come from the patients themselves sometimes. So to give you an example, if you were to break your leg and you're having a hard time ambulating and getting around, you still have to get up and move around and make your meals and maybe travel. You figure out how to do that, right? So maybe it's a certain way that you have your crutch or your cast or wheelchair, but you figure that out so that you're innovating, in some sense. And we had the College of Medicine has basically a make-a-thon where we invite all these ideas from the community, from parents, from faculty or physicians, even grade school students apply, but to share their ideas, their health innovation. So I think we have to pay attention to the fact that ideas can come from anywhere. And usually it's the people in those situations where they have to innovate.
And I think you were in a situation that you described in a video where you had, if I remember correctly, some type of cancer. And, going back to that story, how do you think that affected you? What were some of the challenges? And you're here today. So
yeah. So I'm a cancer survivor. I had very near death experiences, and medicine saved me. And I tend to think I like to say that well, as engineers, we solve problems, right? And that's what drives us. But engineers can't fix everything, right? There's a point where, in this case, medicine and physicians came in to save me, to solve these problems. And so recognizing that, and a lot of, I survived because of very early, stem cell therapy, bone marrow transplant therapy that was able to kind of, restore my immune system. And so, looking back at that has always been a strong motivator for thinking about how to solve problems in healthcare, to respect and recognize what it's like to be a patient, right? To be somebody that feels very powerless at times, to be at the mercy of a system, right? To have to rely and develop trust with a physician who's, is going to be making life or death decisions for you. I mean, these are really profound moments, right? That patients have. And I think without having been a patient, I would have never understood that. And so I think being a doctor, I have a completely different view of the patients that I see and treat and think about. And so it's one of those experiences that has always been really rewarding in the end, although it was very difficult to get through.
How long ago was this?
So that was about 30 years ago. So, like I said, it's just been a strong motivator for almost everything else that I do. And developing technologies that could, have an impact on, general health and people, worldwide.
Yeah, when you have these like moments of realization about how fragile your life is, I think if you come out of those, it just gives you like it's a really good motivator in figuring out how much you need to do or how much you can do and how grateful you are to be where you are right now.
Yeah.
This doesn't compare to like you went through cancer, but so I had COVID once, right? And nothing compared to cancer, right? It's very minor, but it's like even then coming out of that, you realize, okay, there's so many things that I take for granted about myself.
Yes.
Right. And you need to be more grateful and like making the most out of your time. I think it's like a wake up call. Like you realize, okay,
it is. I think, everyone takes their health for granted.
Right.
And until something goes wrong. And then you wish you had not done that. So, how do you inform people not to do that, not to take it for granted, other than these strong life lessons? I think as people age, they start to realize that too, right? I mean, you don't heal as fast. You've got, more and more joint aches and,
It's a reminder.
It's a reminder, right? That we are here in a finite period of time, that we talk a lot about, someone's lifespan, right? How long you live. But I think it's also important to focus on the health span. Like, how long are you healthy? Right? And that ideally you would want to be healthy up until the day that you die.
Right.
But, but I think trying to figure out how to expand that health span is equally important as a lot of our efforts to try to expand our lifespan. Right?
If you don't mind me asking, but what were some of the things that were going on through your mind when you were in that period where there was a possibility that you might not be able to make it?
Yeah. I mean, there was a lot. Obviously, I think that the odds were terrible. I had a 30% chance of survival, based on just how aggressive the treatment is and just the likelihood of recurrence. So terrible odds, but really, this sense that you have no choice but to go forward, right? And you could either give up, right? Or you can fight, and you could really try to develop a positive attitude and go forward. I think that we talk a lot about spiritual, people's spiritual relationships or religious affiliations. There's something tangible there too, right? I think that the mind, the spirit, the positive attitude, in healthcare is a real thing. People that medically may be doing well, but if they have a poor attitude or outlook or hope, have lost hope, they don't do as well. And so I think that's something that we, tend to forget about sometimes in the whole holistic treatment of a patient. Other thoughts were, why me? The chance of such a, somewhat rare, disease, for someone that's so young, and so trying to, from an analytical mind, trying to figure out, maybe what had happened, right? What was the cause of this, but never really kind of coming up with that answer. So a lot of questioning, why me? Questioning, or just recognizing the value of personal relationships and family. Again, something we sometimes take for granted,
right?
Without those. And then in the end, and even to this day, it's like, why am I here today, right? Why did I survive? What's someone's greater purpose in life, right? I think everybody has a purpose in life, and how do you figure that out? Right? I don't know if if so many people really think about that, and how many people act upon that. But I think it's something we all should think about. Why are we here? Like, what's our purpose in life? What can we do? Is it for the good or for the bad? What can we do to make not only our lives better, but other people's lives better?
And what's better than be a doctor and an engineer?
Well, it's given a toolkit to do a lot of different things. Right. And I think even in the research I do as a professor, I think that's what has given me, a background and really a lot of capabilities to do both, right? To be able to develop engineering technologies and then also apply them to improve human health. So
when you look at the future of your research, because you've been doing it, we were talking about before that you've been here for 30 years as an undergrad and as a professor, and you've been as a professor 23 years, and I'm sure you want to continue and find more things. So when you look at the future of your research, what are you excited about now, and what are you looking forward to in the future?
Yeah. So the research we do is in thinking about medical applications for our technologies, and so we've got to the point where we have systems that are seeing things in tissue and cells, that indicate disease. We see a lot of potential for this to be new markers, biomarkers, to detect disease or monitor disease, and so I think what motivates where I see this going is to the point where these technologies can have a broad impact and really improve the standard of care for healthcare for many, many patients. Early on in my own career, I was seeing patients and I was doing research, and I had to really kind of think about, is this the path I wanted to continue on? In my field of internal medicine, I saw a lot of very sick patients, and I did my best at treating and helping them, but it was really one person at a time. And while there was a strong personal connection, I really loved that, connecting and developing relationships with patients and helping them. It was just still one person at a time. And I realized that with technologies, with innovations, if I could change the way that medicine is practiced, I could affect millions of people. And so that's what's kind of steered me toward more of the engineering and these technologies. So what I see would be most rewarding is when we have these technologies that start to really impact people's lives, saves lives, improves their lives, and we're starting to see that now. So that's been really exciting.
This is also what drove you to start your own companies? Like this, like you can affect the lives of millions of people.
Absolutely. Yeah. So, as a professor, as faculty, we have research labs, we train students. But if we have ideas, we've got to get them out. We've got to disseminate those. And very often a research lab in a university isn't set up to do that. And so that's the role that industry and startups really play, is to take those ideas from the lab and now disseminate, commercialize those. And so I always have this diagram that I refer to. Oftentimes we'll talk about translational research. And that's bench to bedside. It's a bit of a cliche. So taking ideas from the bench, the lab bench, to the bedside. So do they work in patients? But I would contend we're only halfway there. So that may be translating research, but we have the other half, which is transforming healthcare. And to do that, we have to go from the patient now to the population. And we have to take our technologies, benchmark them against the standard of care, the way that we're doing it now, and show that it's better, and then figure out how it can be adopted and replace the standard of care. So that's a whole nother career endeavor to make that happen, and that's where startup companies come in. So I started 4 startup companies. All of them were to commercialize the ideas out of the lab and to make them more broadly disseminated. And that's what's really rewarding, is now companies that have products that other doctors are using that are really helping other patients. And that's ends up what we need to do.
What do you do when the standard is not good enough? Or what if the technology you're proposing is beyond the time the standards were made, and now you know that it needs to change, but
Yeah.
they've already been in place for years. So.
Yeah, really good points and questions. And the whole reason for doing the engineering and the technology in the first place is because we think that standard of care is not good enough.
Right.
Right. So that's the problem, right? That we're trying to solve. And so, we keep that as our focus. We develop that technology, and ultimately we want to show that it is going to be superior to that standard of care. Now, there's a lot of hurdles along the way, obviously, and one of the things I've learned as engineers, we love complexity. We love labs filled with knobs and gadgets and complicated systems, but that type of a system is not, does not succeed in medicine or in healthcare because it's too complicated. People won't use it. It won't be adopted. Right? Maybe it gives too much information. Again, as engineers, we love the more data, the more information, the better. But in medicine, too much information just becomes confusing. And we have to distill that down to the most important bits of information for the medical decision making that has to take place. So, so I think that, these are the role of startups in industry is absolutely essential to really work and improve in healthcare.
It is in a way the role is to disrupt the status quo in a way.
I wouldn't say you're correct. I think thinking from an engineer, we think about disruption, but a disruption in medicine is too big of a jump. Right?
Oh, okay.
And it wouldn't be adopted, right? So I tend to think, that's what we go into thinking. We're going to completely change the system.
We revolutionize the world.
Yeah. But it's got to be more incremental, and again, if it's too complicated, if it's too disruptive, and for very good reason, right? Because there's people's health and lives at stake, and we can't experiment, right? It has to be really tested and robust, and so I think that medicine, new technologies and ideas in medicine have to come incrementally. They can't be disruptive.
In a way, we risk that some technology comes along and perhaps not ready yet in some way, and then that pushed the whole field back in for 20 years. So that's why it's a good point that in some fields, yes, you do want to disrupt as much as possible, but perhaps in medicine, just a whole different target demographic that one little mistake could just push back the field 20, 30 years.
Absolutely. I mean, I think that there's nothing worse than spending 20 years on a technology and you've commercialized it and you're trying to get it adopted right into the workflow, but maybe it requires too much training, right? Or it's giving you information that's not as useful, right? And it doesn't fit in the workflow, and it's just not likely to be adopted. And so it's a shame that such a great idea would have to die there. So how do you prevent that? I think that's where, again, you get physicians and you get patients and nurses and to work with engineers in that process, right? Or you get engineers and transplant them into the clinical setting so they can better understand that workflow. And this is that interdisciplinary connection that's important.
Do you wish more of your colleagues would start startups and this kind of different projects?
I think that a fair number do. I think many recognize that again, to really disseminate a technology, you have to commercialize it in some way, whether that be a startup or whether a large industry adopts it, licenses it. And the problem is, I think for a lot of our technologies in my space, large companies see them as risky, and so they want the startup company to form to de-risk the technology, to show that it's effective, and then it might be acquired by a larger company. So that I tend to see that as a pathway more often that takes place in at least the medical device field. But yeah, no, I think there's many different pathways for these technologies to kind of get out there into commercialization and use.
What's a problem, in your opinion, that is worth solving right now? Like, if you had all the time in the world, which problem would you choose to solve?
Yeah, there's lots out there.
Yeah.
What I'm seeing is the problem is the data. So we have so many opportunities to capture so much data that we don't know how to manage it effectively and make use of it. So medical imaging generates all this data. Pathology, wearables, our sensors, all this information is coming in, but we don't really make use of it effectively.
Right.
And so, the same thing with like the medical data management, how your own medical record information is stored, is shared, is distributed, is owned, who owns that, who controls that. So I think, and that's only going to get worse. I think we're going to get more and more data. And so I think these systems that can better understand how to use this, of course, how to make use of the data, analyze the data, but still maintain privacy and security is going to be really important. So I see that as our next big challenge.
Would that be something that you would want to work on? Is that you're saying that's something that the society as a whole is trying to like go?
A little both. I think that, here on our campus, we've got this incredible opportunity to rethink technology-inspired health. We've got a charge from our chancellor to rethink how technology can improve health, how we can become more innovative around health. And so resources like our National Center for Supercomputing Applications, College of Engineering, many places, our partners, Carl, OSF, Mayo Clinic, where we have clinical data, we have these opportunities to really think and innovate around these problems. And if we can do that and demonstrate this feasibility, then we have to think about how that can scale across the country, even globally, and make these changes. But I think we have a very exciting opportunity here at Illinois, in this space. We've got a cancer center that is technology-based. We've got a College of Medicine. That's the first engineering-based College of Medicine in the world. We've got, NCSA, a College of Engineering, Applied Health Sciences. We have so many units that really are at the cutting edge that could really impact, our health and improve upon that in many different ways.
If you were our age or even younger freshmen, what kind of problems or people or centers would you want to work at, or what kind of things would you be thinking about?
Yeah. I do think health in general, health in society, technology in society, how those all interface is the area that is going to need a lot of attention, and would be the focus. And very much because we have social issues, we've got social innovation is needed, we've got healthcare disparities, racial disparities, we've got a lot of what they call the social determinants of health, that affect people's health and livelihood, that really needs to be innovative and develop new models, new approaches, new care. And so I think that's going to be, some grand challenges that emerge. We also have a changing climate, global climate change. And so that relates to our health. It's starting to impact our health as well. So if you think about our health, that's the one thing that all of us, take very personally. We all want to be healthy and live happy lives. And so it's something that should be motivating for all of us.
How do you make that happen, though? How do you inspire more people to focus on the right challenges?
Yeah, well, I think that the younger generation sees these grand challenges out there, and they're people are motivated. They may want to solve, like, I see the poverty and that bothers me, and I want to solve, the problems around poverty. I think we have to think about educational systems that are not discipline-based, but problem-based.
Agree.
Yeah. I think that, what would a college degree look like if I wanted as a freshman to solve problems in poverty? Right. And let me design it. And there are ways that you can tailor your undergraduate degree program and studies to really, build that skill set and that training. But I think providing more of those opportunities is going to be very important, because I would put the question on each of you, right? Starting at the university, were there things that bothered you, problems that you wanted to solve, or why did you choose, the discipline that you did? Was it because of some larger vision that you had or goal that you had?
For me personally, I came in with the goal to contribute in solving climate change. Like, that was my motivator. Like, I felt like I could have done like environmental engineering if I wanted, but I thought something more robust and something more, because I like technology and like getting my hands dirty, and I feel like that is one of the parts that's going to play a role in solving climate change. Like, sure, there are going to be legislations and like a lot of coordination that would be happening on the side, but technology also has a role to play. Like, there are companies like the ocean cleanup or like carbon capture, all of these, right? They're all just using technology to solve a problem that is plaguing the entire planet in a way, and it's going to be affecting a lot of us very fast, very soon. So how can I make the best of my 4 years here, and what can make me more capable in contributing in solving problems that you cannot even fully understand as humans, but know you need to solve. So that's why that was my motivator.
Yeah, absolutely. So, I think, I'm not sure if you have a story as well to share, but
well, perhaps not as interesting, but yeah. So I mean, if you can talk to someone and convince them to let me do a major based on a problem, because I mean, I started as engineering, but a lot of it I started experiencing diminishing the lot of diminishing returns, meaning a lot of effort, a lot of homework, and little return in the sense of like, yeah, should we use this one point, but it doesn't really matter. So I'm in the process of creating my own major, but it's a pain to put it in nice terms. So yeah, I mean, ideally, like my goal would be to one of the things I would like to work on is like how do you advance the human intellect and align the incentives of the world. And if you do those two things, you could literally solve any problem. So at a more meta level.
No, I agree. And I think that's what, as an educational institution, we need to think about. We need to think about, providing those opportunities for those entering students that have this vision, that want to solve a grand challenge. How do we educate them, prepare them to be able to do that? And when they finish, when all our graduates finish, to have prepared them not necessarily just to enter the workforce, but to think about, graduate school, think about, policy, think about entrepreneurialism, starting a company, working for a nonprofit. I mean, thinking about more broadly, right? That this education prepares them from many different opportunities. It's to open the doors, not necessarily just for one career.
Yeah, and like colleges used to be about, okay, it's a place where you go and learn how to think, but it's become more of a, you come to college, you can get a job. And which is fine. I mean, we've talked to the dean of the engineering school and kind of not very useful over time, but it just basically, the response we got was, it works for most people, therefore it's good. Which is, like you say, maybe if people, they do want a job, they're here for the job, like, let them. But there should be more system for people who, they may not care as much, or like their goal, the purpose of life is not to get a job, but you think deeply about these questions. And sadly, that's not a thing here yet. And I don't think it's a thing anywhere else yet. So like, what are the other options? So.
Yeah, absolutely. And I think, as faculty, as educators, we think about this all the time. And again, we really want to educate, develop students so they have much broader opportunities when they graduate, that they could think, and pursue many different paths. And they're not just trained kind of in one particular area. It's always there, right? It's just to give options, not to limit them in any way.
Sure. What advice would you give a student, or like anyone who's listening, watching, about, regardless of whether a student or like anyone who's curious? And
I think to have that open mind and to be that lifelong learner. I always like to tell students that are here, whether they be undergraduate, graduate students, anyone, that this is such a unique opportunity. Any academic institution is a unique opportunity because you're here getting an education, learning, but it's this opportunity to interact with students and others from all around the world, right? They've come here together. Similarly, to go to seminars and lectures of world-leading experts in different areas. They come here to you, right, and present a lecture, and it's an opportunity for you to go and listen, learn, and ask questions. When you leave this academic institution, it becomes infinitely harder to be in that type of environment, right? How often on a job do you get to interact with a world leader in some particular field, right? So it's the opportunity to take advantage of that while you're here, to think broadly. You may be in engineering, right? But but pick up a medical journal, once in a while, or go to a seminar, right, in medicine, and listen to the problems that they talk about, and think about how, the work can be done across these fields. So I think just take advantage of that unique opportunity you have while you're here, and then figure out how to continue that learning, after you leave.
Especially Beckman, there are always so many things, interesting things that are
Mhm.
happening. And in Beckman, it's not a place where people just randomly come. They need to want to come.
Yes.
But Beckman's, it's probably one of my favorite places on campus because there are seminars all the time and
Mhm.
people, really interesting people like you. So Beckman is one place I would recommend.
I agree. I mean, our campus is known for its interdisciplinarity. It's known for very low barriers between institutions, between departments and colleges. And so we have Beckman, we have the Institute for Genomic Biology, we have the Prairie Research Institute. We have these what are called interdisciplinary research units. And we have far more than those than many other institutions. But those are the opportunities where people come together. And so as students or researchers taking part in any of those activities at those institutes, you'll get exposed to all that breadth and many ideas too.
Perfect. We have a section at the end of our conversations that we call underrated or overrated. So we basically tell you a statement or something, and then you say underrated or overrated.
So underrated or overrated by whom? By society?
No.
In your opinion.
In my opinion.
Your opinion.
Okay.
Yeah.
So
Okay.
you grew up in Hartford, Illinois,
Yep.
and then you ended up going to Harvard. So those two Harvards, overrated or underrated?
Interesting question. Well, I mean, each one is different, right?
So both.
I think that, I would think maybe, this is harder than than it seems, but I would say underrated for both in some sense, meaning, so Harvard, I grew up as the town of Harvard, Northern Illinois, small dairy farming community, population of about 5,000. My father grew up on a farm there, very rural. Underrated because I think that the farming community, our agrarian roots are really a source of innovation. And a lot of innovation comes out of areas of limited resources because you're driven to be innovative because you don't have the resources. So I think it's underrated. Our agricultural communities, our small towns, they're underrated. Harvard University, I think, is underrated in a sense that there's so much potential there, and even more potential than we know of. And I think that taking advantage of that, underrated if there's opportunities to really interact. Harvard is in such a lead. Harvard University is in such a leadership position among academic institutions. It can do incredible things and bring about change. So maybe it's underrated in a sense that it could do more, right, than what it has done.
How have you seen the institutions change, like when you were a student here versus now?
Yes. Yeah. So I would say that the institutions changed, but my perspective changed dramatically too over time. So as a student here, I just saw incredible opportunity, for research and to get involved and work with, faculty and explore ideas. I think over time, the University of Illinois has just grown to be this incredible place for supporting interdisciplinary work, to thinking very broadly. Like when I finished my MD PhD and I looked around at where I would start my independent faculty position, it was Illinois was at the top because they were the most flexible, that they had opportunities, they were open to new ideas. And I didn't see that at many places.
Another one, all the wearables, as like you mentioned, Fitbit, Apple Watch, right? They're all like monitoring our health in some way and like telling us how we're doing. And so those technologies as an accurate way of telling you what's going in your body, like as good health indicators.
Yeah. So I would say
underrated or overrated.
Yeah, I would say that's overrated. Only because that's just scratching the surface, right? I mean, yes, you can sample number of steps, you can heart rate, maybe blood pressure, some other things. But and so a lot of emphasis has been placed on that. I think what's more important is that, as I had mentioned, that these allowed us to become more in tune with our own physiology. So that's more important than the actual number, I think. But there's still yet more to come. So a lot of the wearable technologies are just expanding, and we can get much more sophisticated data out of those. So I think the current way, that those are commercialized and sold and available is kind of overrated, but there's a lot more to come.
How much do you think we can actually miniaturize? Because all of these technologies, the goal is that you can bring something that huge machines used to do into something that you can wear on your wrist.
Absolutely,
right?
Yeah.
So what's the limit of miniaturization of these pieces of technology?
Yeah, and this is where electrical engineering and photolithography and all this comes in. We look to people like John Rogers, who is here as a faculty member now at Northwestern, but he has been really innovative of wearable technologies and miniaturizing a lot of these sensors into tattoos, into biodegradable sensors, and I think it's only going to continue to improve. So that we have the capacity. We've miniaturized our integrated circuit and our semiconductor systems to the nanoscale. I think that our sensors will follow that too. But not only do they have to be miniaturized for like a wearable, but just again, you don't have to have a miniaturized sensor for the environment, for the room, things embedded in your shoes or clothes or other wearables. So I think it doesn't all have to be miniaturized to really generate the data we need.
Yeah, I guess the miniaturization is just for more convenience in a way for people.
Sure. Yeah.
And then last one here, our friend Earl.
Earl.
Overrated or underrated?
So as a model, we use Earl, and Earl, spelled EARL, right, is also is short for ear. So we use Earl as a model to test our imaging devices in the ear. So I would say maybe Earl is underrated in the sense that what we learn from using Earl to test our systems is really changing the way that we're going to be looking at the ear. And so I think that, this is one example of the impact of technology. So almost everyone has ear infections growing up as children. And as their children age, some will have chronic infections, some will persist into adult life. But, being able to understand the ear infection and diagnose it accurately. Most physicians only get the diagnosis right 50% of the time because they're just looking in the ear with essentially a magnifying lens and a pen light. But with imaging, we can see behind the eardrum, we can see the infection. And so I think Earl and the role that Earl has played in this research is underrated because I think that there's going to be a lot of scientific advances that come from that.
When is he going to be getting a companion?
Well, we've moved from Earl to humans. So we do a lot of our studies in patients now. So our companion, Earl's companions are probably the children and the patients that we image.
And I think with that, it would be a great place to end. Usually we say thank you for coming, but today we came to you. So thank you for letting us come to you.
No, my pleasure, and really enjoyed the conversation, and I hope I hope from this comes insights, deeper insights. I think what you're doing, right, to get this word out, to share these stories that people have, is so important because I think that's lost very often. It's lost in our digital age, to be able to tell stories, to share experiences, and to learn from one another.
And the people like you are actually people, and not just some person in a website or some professor like really far. Just a person that also has a story and something cool to learn.
I agree. Thank you.
Thank you very much. And thank you for watching. I hope you enjoyed learning about motivators, biophotonics, and finding ways that can inspire you at college and finding ways you can learn more. It's a recurring theme of the show, and it's people like Dr. Boppart that keep reminding us of how valuable the time that we have here is. There's so much you can do, so much you can solve. We mentioned how his cancer was a motivator to do the things that he's doing today, and that has led him where he is right now. We often take our health for granted, and me personally, I know that I do often take it for granted too. And there are so many things in life that we never give a second thought about, but are so valuable. We only learn through maybe some harsh experiences or anything that happens to us. So take care of yourself, keep learning, and we'll see you guys in the next one. Thank you.
Thanks.
Awesome.